So, let's talk about one of the biggest, oldest, and most profound questions we humans have ever dared to ask. This isn't just about science. It's a question that digs deep into philosophy, into culture, and into our very sense of who we are.
Right? Just listen to it. Are we alone in the universe? It's such a simple question, but the implications are absolutely staggering. Are we just some lonely cosmic accident? Or are we part of a vast cosmic neighborhood we just haven't met yet? It's a question that really gets the curiosity going.
And what's so incredible is that in our lifetime, how we approach this question has totally changed. I mean, it's no longer just a cool thought experiment for philosophers. It's become something we can actually investigate. A real, disciplined, scientific inquiry. It's not easy for sure, but we have the tools now, the telescopes, the probes, the methods to actually go looking for answers.
So, how did that happen? How do we go from just wondering to actively searching? Well, it all started when we began to see the universe not just as a bunch of pretty lights in the sky, but as a real, physical place.
I mean, just look at this shift in thinking. We went from seeing stars as, just distant lights, to realizing they are other suns, just like ours. We went from guessing about other worlds to knowing that planets form around those suns all the time. And maybe most important of all, we started studying life not as some divine miracle, but as a natural process, a process that could, just maybe, happen somewhere else.
And this new way of thinking about the cosmos, it led to what is, without a doubt, the single biggest game changer in this entire search. The discovery that our galaxy is absolutely packed with planets.
Over 6,000. Just let that sink in. 6,000 confirmed planets outside our solar system, and honestly, we're just getting started. It turns out that making planets isn't some rare, special event. It seems to be a totally normal part of a star's life. Our Milky Way isn't just a galaxy of stars, it's a galaxy of worlds. This quote just nails it perfectly. The script has totally flipped. Because there are so many planets out there, we don't have to wonder anymore if the basic ingredients, worlds, are available. We know they are. The new question is, which one of these countless worlds might be the right kind of world? And that, right there, is the next step. It's about taking this huge cosmic census of planets and starting to narrow it down. We're looking for worlds that could actually support life. We're on the hunt for habitability. Now, our idea of what makes a world habitable has gotten way more sophisticated. You've probably heard of the Goldilocks zone, right? Not too hot, not too cold, just right for liquid water. Well, we've moved beyond that. Now scientists know habitability is more like a complex recipe. You have to consider a planet's size, its atmosphere, its geology, even what its star is doing. It's a whole spectrum of possibilities. And this wider definition has opened up some wild new frontiers, some of them right here in our own backyard. We're talking about looking for life in the huge oceans hidden under the ice of Jupiter's moon Europa, or on Saturn's moon Enceladus, which is literally spraying its ocean out into space for us to sample. All of a sudden, the number of potential places for life has just exploded. Okay, but here's a super important distinction that scientists are always careful to make. Habitability is all about potential. It means a world could host life. Inhabitedness means it actually does. Science has to move one step at a time. First, you find a house that looks livable. Then, you knock on the door to see if anyone's home.
So once we've zeroed in on these promising, potentially habitable worlds, what's next? How do we actually look for life? How do we try to listen for its echoes across all that empty space?
Well, scientists are basically looking for two kinds of clues. On one hand, you have biosignatures. These are signs of any kind of life, even just microbes. Think of weird combinations of gases in an atmosphere that just shouldn't be there naturally. Then you have technosignatures. These are way more specific. These are the signs of technology, things like an artificial radio signal or maybe even industrial pollution in the air of a distant world.
And all of this brings us to the famous Drake equation. Now, it's really important to know that this isn't some magic calculator that's going to spit out the exact number of alien civilizations. That's not its point. Its real genius is how it takes one gigantic, overwhelming mystery and breaks it down into a series of smaller, more manageable questions. It's like a roadmap for research. It helps us figure out what we know, what we don't know, and what we need to find out next.
Of course, all this searching leads to that big, looming question known as the Great Silence, or the Fermi Paradox. If there are so many potential places for life, why is it so quiet out there? But, most scientists don't see this as some kind of depressing contradiction. They see it as a hint that we need to check our assumptions. Maybe we're not looking in the right way or for the right things.
And honestly, to say the universe is silent, well, that's putting it mildly. To put our search into perspective, it's like we've gone to a cosmic ocean, dipped a single glass into the water, pulled it out, and because it's empty, we've declared there are no fish in the entire ocean. The truth is, we have barely even begun to look.
And this is where the whole thing gets really deep. Because this search for others isn't just about looking out into the stars. It's also about looking inward. It's like holding up a giant mirror to ourselves, to all of humanity.
Let's just think about this for a second. What if we keep searching with better and better telescopes, and we find a universe full of beautiful, habitable worlds, but they're all empty? What if the silence just continues? That result, finding nothing, would be just as world-changing as finding something.
Because if it turns out we really are alone, or that intelligence is incredibly rare, then what we have here on Earth becomes unimaginably precious. It would mean that consciousness isn't some cosmic default, but a fragile, flickering flame in the dark. And that would put a profound, heavy responsibility squarely on our shoulders to protect it.
So, when you boil it all down, it really comes to this. We're in one of two situations. Either we are on the verge of joining a vast galactic community, or we are the sole guardians of something so rare it might as well be a miracle. Both of those possibilities are completely awe-inspiring. Both of them demand our wisdom, and that is why this search, no matter what we find, will always matter.